Let's suppose someone wanted to build a quantum computer and then he went to physio.com channel on YouTube to watch the educational series Quantum Computing. And then he went to the lab and successfully isolated some electrons and changed their quantum states by manipulating the energy operators in the Schrödinger equations using external magnetic fields. Now, after he built his quantum computer and downloaded the operating system, Windows Quantum, he wanted to use Facebook on that quantum computer. Using the principles of quantum mechanics, we will explain the 12 setbacks of using Facebook on a quantum computer. But wait, there is one good thing, and that good thing will outweigh all the other setbacks. Let's start with the no-cloning theorem. This theorem in quantum information physics says we cannot copy or paste any content using a quantum computer. And that's because if we have a certain quantum state and wanted to create another identical but separate quantum state, the process of copying is invalid in quantum physics. This is what's called no-cloning theorem. And the second setback of using Facebook on a quantum computer is the no-delete theorem. You cannot delete any content using a quantum computer. Simply because if you have a quantum state and you told that quantum state something, the quantum state will never be able to forget it. They're not good at keeping secrets. Another setback for using Facebook on a quantum computer is that you cannot go live. You cannot broadcast videos over Facebook. This is what's called the no broadcast theorem. This theorem in quantum physics is a generalization of the no-cloning theorem. It simply says we cannot convey one quantum state to two or more quantum states. The fourth setback is the no-hiding theorem. This theorem says if you find some content in Facebook that you distaste, you cannot hide it. And that's because if we lose a quantum mechanical state out of any quantum system for any reason, it will not disappear forever. Actually, it will just move to another environment. We all have learned the concept of wave function in quantum physics, which is a superposition of all possible outcomes. Quantum programming works in a similar fashion to classical programming. It consists of three stages: input, process, and output. In quantum programming, output and input are both wave functions. Now, if you still insist on using Facebook on a quantum computer, what would it be to experience that? The first thing you will realize, everything on your Facebook account, your news feed, your home page, your mail inbox, everything is displayed by the means of wave function. Since we said the output is a wave function, that means you will get a probabilistic outcome. Let's give an example. When you receive a message, it will appear to you as if it was sent from all of your friends, with some probability distribution, of course. That means if you expect a message from a friend, it's more likely you will receive the message from that friend. Now, you cannot tell what friend you received the message from until you click on that message, and that's when the wave function will collapse. And this wave function will not only collapse when you check something on Facebook, it will also collapse when any of your friends clicks on something on Facebook. So, what it appears to you as a random event on your Facebook account, it's actually the wave function collapsing all the time. Let's raise the weirdness level of using Facebook on a quantum computer and talk about the quantum interference. Let's say you want to check your Facebook page to see which ones of your high school friends will go to the concert next weekend. You will see that either all of them will go to the concert or none of them will go next weekend. So what happened here? Two wave functions interfered with each other and manipulated the probabilistic outcome of some observable. The same way, you can find that all of your neighbors, for example, will go tailgating next weekend. Another weird thing you may experience if you use Facebook on a quantum computer. Out of a sudden, two of your friends will start to share the same posts and write the same comments and do the same reactions. They will act as if they are one account. That's called entanglement. Two quantum states can entangle with each other and behave like one. Or you may see your friend who hates baseball posting a lot on Facebook about baseball. Or your another friend who hates soccer posting a lot also about soccer. So what is happening here? It's called quantum tunneling. One quantum state can tunnel into another quantum state when it's close enough. Another setback for using Facebook account on quantum computer is the effect of decoherence. Decoherence happens when the wave function collapses due to interaction with the environment, and you will see that as a loss of data out of a sudden. And one more thing you will realize, sometimes you will not be able to communicate with some of your friends. You will think they blocked you. Actually, they didn't. This is what we call the no communication theorem. You just became entangled with them. When two quantum states become entangled with each other, they cannot communicate with each other. Now, the good thing for using quantum computers to access your Facebook account is what we call quantum cryptography. That means no hacker, no matter how advanced he is, cannot access your account without you knowing someone's trying to access your account. That's because if there is someone trying to access your Facebook account, that will cause the wave function to collapse, sending notifications to everyone that someone is trying to access that account. Some people said it's a good idea to use quantum computers to access Facebook accounts because of the higher level of security, as we said. Also, they said, in case we are uncertain about some event on Facebook, we can always use classical computer to check on that. And the same people say we will never need a classical computer in the future when our brains are trained enough to deal with quantum physics.